Okay, so here's my Proxmox server. It's my own personal system. I'm running Proxmox VE, which is the hypervisor. VE is virtual environment. And I'm going to log in here. Okay. It says you do not have a valid subscription for the server. That's fine. That's just part of their licensing. I'm using the free version. If I wanted to use some more advanced features, then I would need to pay for it. But this is the free version, so it's fine to use this as the free version. I've already got a couple of VMs on here. The system itself, just a lone system, and it says 32 CPUs. It's a 16-core processor with hyperthreading, so it shows up as 32. And I've got 48 gig of RAM, which one of my VMs is using up quite a bit of. So, but we're going to go ahead and install I'm going to walk you through the installation of the NERD Autobox. So let's go ahead and create a VM. We're going to call it NERD Autobox Demo. The OS we're going to use, I've got a couple different volumes on here. There's a 4 terabyte SSD in here, and so that's where most of the stuff is stored. I'm going to use the Alma Linux minimal ISO that I downloaded from the Alma Linux website. You don't need anything other than the minimal one, so it'll save you some time in downloading it and save you some space on your storage. Definitely, you should be using some sort of flash storage for this, whether it's an SSD or NVMe drive. You're not going to be happy with the performance you get from a spinning disk. So you could use like a spinning disk for backups or archive or something, but any active VM should be on flash storage. So system will leave us the defaults. For the disk, I'm going to go 100 gigs. You can make it bigger if you want to. I think 100 gigs should be fine. Probably I would say the minimum would be 50, but I'm going to do 100 here. And CPU, I'm going to give this thing 10 cores. And I'll leave the rest as the default. For memory, I'm going to do 24 gigs. 2400, or give or take, that's 24 gigs. If you have less memory, you can use less, of course. There's 2 topologies that I've included in the repo for Container Lab, and for the specific container topologies to automate. One of them is large, one of them is small. So the smaller one should fit in like 10 gigs. This one will fit in 20, so I'm going to give it 24. We'll talk more about sizing. It's on the network via VMBR. That's the virtual machine bridge. That's the vSwitch. It's very similar to a vSwitch in VMware. That's what's plugged into the uplinks. So that's fine there. And we're going to use the virtual IO NIC. And that should be good there. And we'll confirm this. Looks good. Go ahead and finish it. So now I've got a new virtual machine initialized. So go to the console. We'll start it up. It's going to boot into the ISO. Boots up in the ISO image, so we want to up arrow to install Alma Linux. We don't really need to test the media. And this is going to boot up the installer. Again, we're using the minimal installer. Pretty quick. You can download the larger installer image that has a bunch of stuff on it, but we use a base operating system, or the base image for the most part. And we add a few things later. So the graphical installer will start up. Okay. So go to continue. And a couple of things we're going to set on here. One is the installation destination. We just click on it. So that disk is selected. It's the 100 gigs I did before. We'll let it auto partition it. It's fine. Software selection, we'll leave that as minimal. For root password, we're going to set a root password. And we're going to allow SSH. You can not do this, but I like to allow root access. We'll create a user account. Do my name, and I'll do make an administrator. This is what's going to allow you to sudo, which will be able to execute commands as root, even though you're logged in as a user. If you don't make this user administrator, you won't be able to issue any sudo commands. And then under network, we're going to set the host name to NERD Autobox. I'll apply that. And then for the network, it picked up a IP address off of DHCP. I'm just going to go ahead and do a manual, set it to manual. Do 192.168.1.29. Subnet mask is a CIDR notation. I'll put some DNS servers in there. It's the same as a gateway in my case. For the rest of it, I'll do that. And I think that's it. Make sure you set your time zone. This is already set to my time zone. I'm in Portland, Oregon. That'll be fine there. I'll do begin installation. Now, this installation process should only take about, generally only takes about 3 or 4 minutes. It's pretty quick since it's a very base install. So I'm going to go ahead and pause the recording and let it finish. Downloading packages. So it's, so I'm going to go ahead and pause the recording while it finishes this process up. And like I said, this should only take about 2 or 3 minutes. All right, so now we're ready to reboot. Installation is complete, so I click on Reboot System. So now it's booting into Alma Linux. I'm going to go ahead and do this part of the installation on the console. Normally I would log in via SSH, but the console is good enough for what we're doing here. So I'm going to log in as user Tony. Put my password in there. Now the first thing I'm going to do is install what's called Coder or VS or Code Server. And what that is, it's a version of VS Code that actually operates on inside of a web app. So that is going to provide us an IDE as well as a terminal into this device, so we can edit directly on this device. We can SSH directly into this device without using any other SSH clients. So from one web interface, we can do everything, which is really fantastic. I really love this software. So going to the my GitHub repo that has the instructions on here. So just pulling, copying, and pasting from the, or I'll just type it in here. I guess we should probably open up a terminal window. Hold on a second. All right, I got a terminal window open right now to the box. So I'm going to copy and paste from the instructions for installing Coder. So this does the basic install of Coder. It wants my sudo password. All right, so it's finished that part. So we're going to now run the commands that it tells us to run in the instructions, which is sudo system control and enable now -- code server at $user. So that's going to enable it in systemd so that it boots up, so that when the system restarts, it will boot up automatically. Now I've got another command that I'm going to run that's from the documentation that it does a couple of things. It configures a local password for Code Server. It enables Code Server to be run on a local port, on port 8080, and opens up the firewall. So this is it, the URL and so forth. This URL might change, but just look at the instructions on the GitHub repo. It says, what password would you like to set for Code Server? So I'll put one in. It doesn't do any it doesn't ask for the password twice. It doesn't do any password complexity checking. Now it says, now restarting Code Server to activate new settings. The config file can be edited, so you can take a look at that if you want. And then it's allowing the firewall on port 8080. So let's go in via the web browser, because everything else that we're going to do from here, so we can close this out. Everything else from here we're going to do through the web browser. So I put in the URL, and I've got it's a self-signed certificate, so that's what it's going to give you there. Put in the password. And then now we have this thing called VS Code for the web. If you go to the hamburger, which is this thing over here, and you go to terminal, new terminal, this will open up a SSH, or not an SSH, it's not SSH, it's a native terminal. So this is the Linux command line. We're going to open up the editor, open up a folder. Let's go ahead and open up the root folder there. Click out of those. I'm going to customize this a little bit. I'm going to set this to, I'm going to pick the color theme to dark plus. This is typically what we see, usually what we see in these demos is this color scheme. So here we go. And the rest of it we can do from this command line here. So I'm going to open up that terminal window again. Switching the color theme got rid of the terminal. The next one is we're going to install Ansible. So it'll be sudo DNF, which is the package installer. It used to be called yum. Ansible core. And I got to give it my password. So it's going to do some updates. That's going to download Ansible core. Oh yeah, there was another command I should have run, dnf-y update, and that just updates everything to current versions. This is a good thing to do, especially after you do an installation, to just get all the packages updated. Okay, we do have Ansible installed and it's updating. We're going to do a quick check of the Ansible version, make sure we're good to go after this finishes. You can open up more windows. So here I've got there's another bash window. I'm going to do, make a directory called, we'll leave it there for now. Let's see how we're doing here. Let's running that. If I do Ansible version, we can see that we do have Ansible installed, 2.14, so that's good. Next thing we need to do is install Docker. So we're going to go to, so this can finish up. It's fine if this is finishing up. Oh, all right, now it's done. So we're going to install Docker. So we're going to need to install -y yum utils, because we're going to add a new repo, and copy and paste. All these instructions are I got from my, it's in a different window, my repo that has these instructions on here. I'm pasting. It wants to make sure that that's going to allow to do it. So I just cut and pasted from the document. So run that command. Oh, I need to install an extra. Yeah, so no match for these. What we need to do install is the Docker repo. And usually, if you look for instructions on how to install something on Red Hat Linux RHEL, then the instructions will work for Alma Linux because they're mostly the same. So what I need to do is, so the package manager, we used to be called yum DNF. It has repos that it defaults to. We're going to add the Docker repo. So I use that command right there. So now I've added the Docker repo. Now I should be able to install these Docker modules. Yep, looks good. So it's going to install all of those. There's also something called Podman, which is another container manager similar to Docker, but I could never get it to work with Container Lab. Container Lab likes Docker. Docker is not open source. Well, some of it is, but we can use it for free. I'm going to update my instruction to make sure I include that little bit in there. All right, so then we need to enable Docker through system control, which is system D. So enable it, that way it starts on reboot, and then we're going to start it. Okay. Now we need to go and download a copy of containerized EOS from arista.com. So go to the arista.com website. You're going to need to create an account. I already have one set up. And we go to software download. And what we're looking for is the under EOS, active releases, 4.32, 4320F. There might be a different version. Just anything recent should work. 4.30, 4.31, 4.32. And then we're looking for CEOS Lab. And we're going to want to download not the 64-bit version, but we want to download the regular version, which is 32-bit. Then the reason is that we're not going to take advantage of having a 64-bit version. I can handle bigger tables and stuff, but we're not going to do that. The tables that we're going to deal with are very small, porting tables, that is. And then it also takes up about half as much RAM. So CEOS, the 64-bit version, I think takes up almost 2 gigs per image, something like that. And the 32-bit version is something like it's like half as much. It's like 700, 800 gigs. Depends on the version, but that's what we're going to do. So we don't want we don't want the software images or anything like that. We just want that one right there, the non 64-bit TARD XZ. So click on that. It'll download to your local desktop. And then we need to get it onto the system somehow. You can use something like FileZilla. That's a good way to SCP. So we just need to get it on there somehow. Okay, so I used FileZilla in a different window, and I uploaded to the system. And there it is, CEOS Lab. I'm going to make a directory called images, or container images, and then move CEOS Lab into there. Just to keep it out of the way. I don't want it just sitting in the root directory or anything. And then the next step is we have to import it into the local image repository. Some images you can just get off of the Docker repo or some other repos, but you do have to download it from arista.com. You will need to set up an account. I think they approve it almost immediately to give you the permission to download those lab images. And the reason why I'm picking EOS is, one, I'm an instructor teaching mostly Arista equipment these days. I have spent most of my career teaching Cisco. Cisco doesn't have a containerized version of a data center network operating system. NXOS is currently just virtual machine only. It's a very heavy virtual machine, uses up a lot of RAM and CPU. Whereas these containerized versions of EOS are very lightweight, they're very fast, they're mostly they have most of the features in them. There's just a couple of things that don't quite work because it relies on, because those things that rely on like physical hardware. But most things do work out just fine, including VXLAN, EVP and VXLAN, including data plane and control plane. So it's lightweight. They don't hassle you. It's on using it for a lab. Like, the Cisco world, sometimes you have to find an image that fell off the back of a truck. But here it's much easier. So I've got that image locally. I'm going to load it into the Docker image repository. So we'll do sudo docker import, and then we'll that images file. And then we'll give it a name. We'll call it CEOS, and the tag will be 4.32. 0f. It's just a name for it, so that's what we're going to call it. So it's going to import it. Takes a minute or so. It untars the entire file. And then loads it into the local Docker repo. Go ahead and pause the video. Sometimes this might take a little while depending on what's going on the hypervisor. There we go. So there we good. There we go. Let's take a look, see what it looks like in the image repository. And it's CEOS 4.32, and it's 2 gigs of storage. So that looks good. And then now we got to install Container Lab. That's in the docs on how to do that. We'll run that command. It's going to download that image. Right now it's 054.2. That's installing that, and while that installs that, I'm going to start preparing the Autobox topologies. All right, so there we go. I'm going to create a new directory under my root directory, and I'm going to call this Container Lab. Let's just call it Autobox. This is all my automation stuff in there. And I'm going to go ahead and just go to File, Open Folder, and we'll just deal with that. I don't have the other stuff in there. So that's going to reopen the folder there. And I'm going to do a get clone of the Autobox topologies. So now I've got a new directory in here. One's called class large and class small. These are both leaf spine topologies. One is bigger than the other. So the large one has 4 leaves, 4 spines, and 4 hosts. So 16 images. The class small has 4 leaves, 2 spines, and 2 hosts. So fewer number of devices. It depends on how much memory you've got. The large class environment, and you can modify this or create your own, but this should get us started. And we're doing the images CEOS 4.32 latest. Let's see if that's what, because we got to match up. So sudo docker image list. But CEOS 4.32. I think this is what I love about this IDE is I can do things like change all occurrences. So it's CEOS 4.32. I think that's what it shows up in here. We're going to do the large one since I've got a big enough. Since I've got a 24 gig VM in here. So we're going to go into the topologies. And I'm going to do Container Lab. Go to class large. Do Container Lab. Deploy. Oh yeah, sudo. Good.read docker config. Oh, okay, I fixed it. I just had the image name was wrong. It's CEOS 4.32. So now it is, I'll just typed in Container Lab deploy. It picked up the topology file, and it's building out the different hosts and everything in there. So it's going to take a few minutes, or maybe not a few minutes. It's going to take a minute or two to start up completely. We take a look at how much RAM we're using in this. So we can see the CPU is pegged out on its 10 CPUs. That's fine. That's normal. It's the startup process. And we're using 17 gigs. We're starting up 16 containers, and we're using up 17 gigs of RAM. So that's about right for about 700 to 800 megabytes per container. All right, CPU has gone way down because the containers are started. Once the containers are running, they generally don't use up too much CPU, even when they're running routing protocols and such. Just that startup process is a little CPU intensive. All right, so now we've got all these set up. It's on a back-end network. At some point, I'm going to update the instructions on how to put it onto your actual LAN. But right now, it's on a separate private network on the 172.20.20 address space. Let's go ahead and log into Leaf 1, and we're going to do a SSH admin, and we'll say yes. Password is admin, and then you've got a functioning EOS config. So that's good there. It automatically creates an Ansible inventory file, which is pretty cool. But we have a fully fledged, for example, if I want to show LDB neighbors, ignore the stuff in there, but we can see that I've ignore any of the LDP results coming out of the management interface. It's sharing a bridge there. So, but our point-to-point links, we can tell where we're plugged into. And I've got Ansible installed. I can start to automate all of this. I'm going to create, so under NERD Autobox, let's create a directory called Ansible. And I'm going to log out of here. I'm going to install some collections. So Ansible Galaxy collection, install arista dot EOS. So this is just going to install the Arista EOS collection, which has some modules that we can use to modify the EOS configuration. That's done. In the Ansible directory, I'm going to put it actually in the, just a minute. Okay, so where are we? Go to the Ansible directory. We'll do a git pull, and that's going to sync up. I just added something to the repository, so let's do a pull, and that's going to sync up. So now I've populated the Ansible directory with an inventory. I gotta fix that because we don't have any border leafs. All right, so it generates an Ansible inventory automatically based off of your environment, but we're going to use one from the repo. So I want to make sure this gets in there because it's going to be way easier to work with this. So we've got a group called spines, we've got a group called leafs, and a group called hosts. And let's go ahead and do add VLAN. So here's a playbook that just does add VLAN to a device, leaf 1, Arista EOS VLANs, VLAN 10, DMZ, and state is merged. So I'm going to do Ansible playbook, add VLAN, and see if that works. Oh, I got to fix my inventory file. Okay. What I'm also going to do is, it gives the devices names that are based off of the topology name. So, but we already have the IP addresses in here, so we can just do a change all occurrences and just give them simple names. So we'll run that playbook. Oh, we need to specify the type. So, so under all, we'll do vars. We're gonna move this up here. Don't worry about it. It'll be in the repo for you already. And we just need to specify that we're going to use network CLI. All right, let's try that again. Clean that up. Paramiko not installed, so we have to install Paramiko. Pretty easy. pip3 install Ansible pylib ssh. So it either wants to use the Paramiko module or Ansible lib pylib ssh. We'll just do the one that it wants. Oh, pip's not installed, so we'll do dnf-y install pip. All that. There we go. And then we should be able to run the playbook now. Oh, it changed, so let's log into admin at 172.20.11. There we go. We got added that VLAN. So we went in about 30 minutes. We went from nothing, just a hypervisor, and we have an automation system, a full automation system. I've got a fully functioning leaf spine topology here. I've got Ansible. I've got VS Code running as a web app with a command line terminal that I can use for doing command line stuff. So that is the purpose of this whole setup, is to be able to get to this point quickly and reliably. I have a few little tweaks to do on the instructions, but hopefully you can see that this is not a very difficult thing to do. It may stretch your Linux skills, but once you get used to this environment, it should be just fine. So I'm going to tidy up my installations, and I hope that you will take this and use it and learn from it and start to play around, write your own labs, and that's it. Yeah, enjoy. Thank you for listening.